Hey everybody, Mr. Quick here. Today we're going to look at Eureka Math / Engage New York Math, Module 3, Lesson 18, Distance on the Coordinate Plane. We're going to be finding the distance between points on the coordinate plane. We're going to count the number of units between the endpoints, and we're also going to use absolute value. So let's go ahead and get started with some examples. Okay, example 1. The distance between points on an axis. So here we go. We've got our coordinate plane here. And it wants to know the points. It's giving you the points to consider here. -4, 0, and 5, 0. What do the ordered pairs have in common, and what does this mean about their location on the coordinate plane? Well, we can picture this in our head. We can also actually draw it out. So let's go ahead and do that. So -4, we're going to go, remember we go, first coordinate is x, second coordinate is y. Here's x. Here's y. So, -4, we're going to go back 4. 0 means we don't, of course, x is side to side, y is up and down. -4, 0 means we don't go up or down. We stay right there. So we're going to mark that spot right there. 5, 0 is positive, so we're going to go to the right of our origin, which is in the middle there, 0, 0. We're going to go over 5 and up or down, nothing. We're not going up or down, right? It's 0. So we're going to mark that. Oops, that's not quite right. If I can fix that. Mark that right there. Mark that right there. Good enough there, right? Okay. So hopefully what you're noticing, since the number in both coordinates is in the x spot, and there is a 0 in both y coordinates, it means that both of these coordinates, both of these points, are on the x-axis. So both points, that's their location on the coordinate plane, right? They're both on the x-axis. As we look at them, since they are on different sides of 0, different sides, like one is negative, one is positive, what we can do is we can look at their absolute value. So -4 and 5. Absolute value of -4 is 4. Absolute value of 5 is 5. -4 is 4 away. Not a very good 4, huh? Is 4 away from 0. 5 is 5 away from 0. So in this case, we're going to add them together, 4 plus 5, to see that the distance between the two is 9 units. And the reason we use absolute value is because they are on both sides of the coordinate plane, and we're basically just adding from here to here. So if we did that individually, we could say, all right, start at -4, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You can do it that way. Or you can look and say, well, -4 is 4 away from 0, 5 is 5 away from 0 in the other direction. Add those two up, they're 9 apart. All right, let's look at another example. Consider a line segment with the endpoints 0, -6, and 0, -11. What do the ordered pairs of the endpoints have in common, and what does this mean about the line segment's location? Well, it's kind of the opposite of the last one, right? We have, I'm just going to write our x, y, right? Our first coordinate is 0 in both cases, so it doesn't actually go over on either the positive or negative side of 0 on the x-axis. So both of these points are going to be on the y-axis because the only number is in the y-coordinate, the second coordinate. So let's go ahead and do this. So we have 0, -6, so we're going to mark that right there. And we have 0, -11. So again, we're not going over, we're just going down to -11, which is right down here. Okay, find the length of the line segment described by finding the distance. So we want to find the distance between these 2 points. Now, what's different about this from the last one is that, so when you go from, I'm going to draw this in 2 colors here. When you go from 0 to 6, we'll put that in red. If you go from 0 to 11, you notice that the red is inside the orange there. Since they're both on the same side of 0, they're both negative numbers, the -6 is contained within the -11. So we're still going to find the absolute value of both. Absolute value of -6 is 6. The absolute value of negative 11 is 11. But in this case, since they're both negative, we're going to subtract 11 minus 6 equals 5. So the distance between the 2 points would be 5 units. If they were both positive, let's say they were 11 and 6. Let's say they're both positive. You would do the same thing. 11 minus 6 is 5. There's 5 units between them. Now, of course, you can also count and say 1, 2, 3, 4, 5, and see that that is the distance. But going back to this original, if you have a positive and a negative, and you're trying to find the distance between them, you add the absolute values. If you have 2 negatives or 2 positives, meaning the signs are the same, then you subtract the 2 values. All right, let's do a couple of more examples here. We have negative 9, 4, and negative 4, 4. Okay, now what's different about this one? The x and y coordinates both have a number, right? But if you'll notice, in the y coordinate, the number is the same. It's 4 in both cases. So let's go ahead and graph these. So we'll go negative 9, so we're going back 9, up 4, positive 4, right? Mark that right there. And then we're going to go negative 4, 4. So we're going to negative 4, up 4. Oops. It's really tiny, so I'm trying to get it just as... There we go, perfect. Okay, so you'll see that since the y coordinate is the same, we're still just looking at the difference basically on that x-axis. Like if that was negative 9, 0 and negative 4, 0, we'd still be looking at the x-coordinate, which is what we're doing now, right? So we're going to say absolute value of negative 9, absolute value of negative 4, negative 9, absolute value is 9, negative 4, absolute value is 4. And just like we did over here, they're both the same sign, they're both negatives, so we're going to subtract the absolute values. 9 minus 4 gives us 5 units difference. So even though it's not actually on the x-axis or on the y-axis, since they both have the same y-coordinate, they're both on the same kind of line, if you will. You can make a straight line between the two. So it's not really any different than if you made the straight line on the x-axis. Of course, the other thing that you could do, and this is just going to involve a lot more graphing, but I just want to show you another way you could do it, or you could even just check your work. Start at one point. 1, 2, 3, 4, 5. Just make sure you count correctly, right? Make sure you get it right. All right. Let's look at the next example here. We have 0, negative 11, 0, 8. So again, the x, y, the x is the one that goes, oops, I'm sorry, that's not right. Yeah, goes side to side. Y goes up or down, depending on if it's positive or negative. So if we have zeros in both x coordinates, the first coordinate in both pairs, then 0, negative 11 means we're not going to go side to side. We're just going to go straight on down to negative 11. Mark that down there. And then we're going to go to positive 8. 0, so we're not going left to right. We're going to positive 8. If I can get it, close enough. Okay, so we're going to go absolute value of negative 11, which is 11. We're going to go absolute value of 8, which is 8. And since we have one which is positive and one that is negative, two different signs, we're going to add these together. So we have the difference in both is 19, or the distance between is 19. You could count and say 1, 2, 3, 4, and you could go all the way down and you get 19. Or you can, this is 0 right in the middle. So from 0 to 8 is 8. From negative 11 to 0, there are 11 spots. Add those together, you get 19. Okay, we're going to look at some more examples of this together in class and do a little bit more work on this. This does kind of show you how the distance works, at least when you have one coordinate which is the same. So we'll talk more about this together. Thanks for watching, and we'll see you soon.